Hey guys! So today you and I are going to talk about refactors and improving legacy code. So let's get into it. So the question in question was, hi Frederick, what are your thoughts on the ways of going about improving legacy code? Do you try to sneak in bits of small improvements here and there, or invest some time to go about it in all at once as a team? This is one of my favorite subjects. It is one of the things that I specialize in figuring out. It's not because I necessarily want to, but it is there is this level, like I like to tell, I've told you guys a few times before, where a software developer will go through certain phases, and the more you learn, the higher your meta thinking about things becomes higher and higher. In the beginning of things, you only think about getting the software to work, and then you become a philosopher and you think about design patterns and abstractions and the nature of things and so forth and so forth. And then you become a senior, and now simplicity and streamlining things becomes more of a thing. And then if you get even further, to the point where now you're leading teams and things like that. And the next level of the whole thing is, okay, so how do I deal with efficient teams and how do I make teams efficiently? And the higher up you go, it's departments, like it's just layers and layers of abstraction. And this is where, like the other day, actually, I had a conversation with one of my heads, one of the head of engineering at my company. So my boss's boss type of person, and we talked about this, and I shared my thoughts on this specific subject. And basically, what I said was that when you're dealing with what I call a systematic problem, because legacy code is a systematic problem, it's not something that you just fix and then it stays fixed, or it's not something that it's just a mistake. It's something that grows over time, and it happens for a few reasons. If you want that fixed in a permanent fashion, you will need to have both coding skills, hard technical skills, and leadership skills in the same person. You will not be able to go about it any other way, because as I've explained, I explained it to, or I shared my thoughts on it at the very least. Because the problem is, if you only have someone who knows the tech and doesn't really understand the business and the overall goals of the company, they are most likely going to refactor things, and in many cases they will spend more time on refactoring than actually providing any business value. And you have no guarantees that the refactor will actually work, because just because they refactor something doesn't necessarily mean that they know how to go about it in such a way that the company can continue scaling on that refactor. You might just have to rewrite it later on. And I've told you guys about that before, where a lot of software developers have this mindset, as the code monkey mindset, that they only focus on their story, and they need to be told what to do and so forth. So they usually have a very, especially more mature ones, they usually have a very narrow understanding of what a good refactor looks like, and what is an important refactor and what is not so important. At the same time, if you have a PM who doesn't understand how to anything besides leadership, and as I like to say, everything, when your manager has no real knowledge of the things that is going on in the company, it's basically like me. Like, as I said, I actually said this to him, and he thought that was kind of funny, and agreed. Where if the only requirement for being a leader in an organization is that I know how to ask other people what they want and what we should be doing, then I can lead a country. I can lead a hospital, and that is usually the base that's the only requirement on most managers within IT, unfortunately. So the way that people usually go about it is because you sort of touch on the two main ways. Either you refactor all the things in one go, you do the big refactor, or you go little by little. So usually what I see happen here is that when you do the big refactor, usually what happens is that people will create these big stories and make a very big investment in rewriting the entire system. And usually what they do, the reason they do that is because they find something that isn't working all that well. The problem is usually that this doesn't work, because what happens is that you shut down all your development process to gain some arbitrary benefit, such as you use a different library, you got to clean up some classes or something like that. But the fundamental architecture of the system is still there. which brings a different sort of problem, because now you've done the big refactor, but the thing that got you into the problem area to begin with wasn't necessarily that you had the wrong framework or you had the wrong tool or so forth. It is the everyday story work that is happening that brings you to that point where things start rotting over time, and that has to do with a lack of vision on the part of the software developers. Like, they don't really know how to structure a system so that it is stable and remains simple over time. And the second part is that you have a work process that actually perpetuates this. So all you're going to do is pay a very large cost for refactoring something to make it something quote-unquote nice, but very often you will just shuffle the code and create a different set of problems. Basically, after you've done this big investment, like put tons of money and time into it, you're going to be in a state where your code is quote-unquote clean, but probably just from the perspective of what you felt was important at the time. And then 6 months later, you're most likely going to be back into the same problem. Or if the team switches, or like you have other people, like they're just going to start to refactor over again. Now the other part is that if you talk about little by little, here comes the next problem. When do you actually know you're done? Because little by little is difficult. I've seen this. It's what I call, this is my personal favorite for most situations. I actually use this as a testing ground to figure out if the team can actually make this happen. When I am in the team, I know that it can happen. Usually it's not as easy when I'm not in the team. But the way I usually see this happen is that little by little basically means that you're never going to stop the migration, and some things you basically can't fix little by little, unfortunately. There are things that you have to take care of as one package, and it might take X amount of time to do that, because basically you can't just iterate a little bit on it. An example would be, let's say that you were using an outdated package or something like that, or a library, and you need to upgrade it to a new version, because otherwise you won't be able to actually use those new tools or whatever you're needing for whatever you want to do, right? You can't like take that little bit by little, or like Boy Scout that in other stories, or do that sort of thing. You have to actually do some investment. And usually I see that these iterative processes, fixing things little by little, this is stuff that you could do on every story for every piece of work that you ever do. Most software developers don't do that, because Boy Scouting is, as I said, it's something that requires you to scope creep on your story, and you're basically hiding work, and that takes a little bit of talent, because if you're Boy Scouting correctly, that's the most efficient way to fix a problem that you have that is adjacent to the issue that you're dealing with. But if you don't have any stories or anything that you can sort of fix that makes sense for the given moment, you're just going to spread yourself thinner. A classic one is that you work on feature A and then you start Boy Scouting feature B, and all of a sudden all your testing and all your regressions might happen in 2 parts of the system instead of 1. But if you do have a feature A that you're working on that you can improve in some fashion, that's very good, because now you can, because the next thing that you're going to do is to focus your testing and your regression testing and like all of this sort of the QA process, if you will focus on that feature, which means that it's beneficial for you to improve that software because it's already going to go in for review, right? So the way I usually go about this is very simple. I suggest to people to do a topological sort, to take a look at, create yourself a roadmap for what state do you want to be in, and be very honest about why do you want to reach that state. Usually if you don't have a better reason than the code is just ugly or something like that, then the reality is that what you're looking for is to create better abstractions or something concrete. You have to break it down into a roadmap of deliverable steps. And when you have done that, when you have a clear picture of what is the end state here, when are you done with this thing, you start looking at all the things that you need to fix in order to get there. So instead of doing the big rewrite, actually break it down. What things do you actually need to do here? And create a roadmap of stories that you can work on little by little to start off with, because often you will find, like I do what I call a topological sort. I look at in which order can I start moving things around. I usually pick the things that are the simplest and cleanest to move, and I start with those and I do them little by little. Sometimes you have bigger, bolder types of things that you have to do a little bit more investment in, but at least you now try to focus on the stuff that will unblock other stuff further down the line, or as I call it, picking leaves. If you think about a tree structure, if you pick the leaf nodes first, then those unblock the next set of nodes, and then those unblock, etc., etc. And that's the approach I usually use. And the roadmap that you put in place is essential, because if you go about it in the way that I'm talking about here, then two things should be happening. One thing is that you should see an iterative approach, which is consistently improving your code base, where you might have stories that you need to sit down and basically do in one go. But you should also have a roadmap, or like a plan for where are you heading with this, and why are you heading this way. And that is something that your team should be aware of, because as I said, if you just start improving things arbitrarily and you don't have an idea of what a good end state for you and your software is, then your team or whoever takes it over, like that architecture thing that you've heard about 100 times, if you can't express that in a way that the others can join in on, then it's, as I said, it's very difficult for you to actually reach that end state, because you're probably after a while just gonna figure out new things to figure out to do, etc. So you don't have a scope defined or anything like that, and it brings a lot of problems, because if the team doesn't understand how the overall architecture should work for the system, and they are behind it, and they feel like they understand how to get there together with you, who might be suggesting the improvement, then, as I said, then it might be that you're just going to improve it for one person, and within 6 months you're still going to have all these issues. I usually find that whenever I do a refactor or a rewrite or something like that, it's always two things that needs to happen. I need to fix the code and create some plan for how to do that, so that everybody can follow along. But often I also have to help the software developers fix the systematic problems that cause the problem in the first place. So what I want you to take away from this is that I usually suggest to people when you do improvements to legacy code, take a look at the stuff that is actually broken and try to have a bit of maturity and figure out what are the things that actually makes the difference here. And I usually say the things that causes regressions on a fairly consistent basis. If you have things that stop you from shipping efficiently, things that causes bugs, or things that actually break the system in some way, these things needs to be addressed. In some cases you can Boy Scout the thing, which is, as I said, if you just look at it as a topological sort, some stuff needs to be rewritten in like a story or an epic or something like that, but there's often very small things that you can do along the way. Try to prioritize that first, because that means that you can still work on feature development and continue to delivering value. Test out whether or not you're actually able to commit to a refactor of whatever you're doing, and make sure that everybody's on board. Because if you do a few small things and you start seeing people getting how to do the things and like how they should approach this problem, then you can sort of waterproof your idea or your architecture that you're moving towards without having to do like this big upfront investment into it. And then you start checking with the developers, and you guys are, when you're doing this and you start working as a team and try to fix this together, you're going to see people learning from that process. And then by the time you reach those bigger boulders, it's going to be less of a hassle for you to fix that, because you're basically unblocking other things that you might need to do further down the line. And you're going to have some practice in the team to actually get to the state that you want to get. And as I said, the other part is very often the teams don't have an idea of how to build a system, or no consensus on like what is a simple and stable architecture, and that's the education part that needs to take place. And this is why I tell people most software companies have issues with this, even if you hire a PM, even if you hire a tech lead, etc., etc., because getting this thing right, a systematic problem like this, acts on both levels. It's both a technical problem, but it's also an education and leadership problem within the engineering team. And if you don't have both of those in place, you can rewrite and fix things as much as you want, and it's just a matter of time before someone else comes in and doesn't get onboarded or get shown how like this architecture should work, or you don't have any technical leadership, and all of a sudden you're basically back to a legacy system again, because you can't just fix tech and then it just stays fixed, because legacy comes from the work process. So if the work process is broken, you get legacy, and it just continues if you don't fix both the code and the work process, or like the systematic issues that you have within the work and how you do work within the teams. And that requires both leadership and tech skills, and usually it has to come from the same person. That's my experience at the very least. Have a great day.